Hello dear students, welcome back to Chandu Biology Classes. So today in this session we will be discussing chemical kinetics. Chemical kinetics for IIT JAM BT 2026 and also 2027. Okay, so now here this session will be very crisp and clear, that will completely focus on your upcoming IIT JAM BT exam only. So purely exam point of view discussion will be there in this particular session. Okay, right. First of all, I will show you the questions that are asked from this session, from this particular chapter. So based on that, we will be solving the questions by understanding the concept. Okay, so these questions are very basic, you can easily answer. Okay, and chemical kinetics is highly helpful in your bio subjects, in your biochemistry and all those things also. So try to understand the topic very clearly and you can answer any type of questions from this particular topic. Okay, right. Let me show you the questions first. So look at this, all PYQs I will show you. I have collected almost from last 10-15 years papers I have seen. All questions I have here from our Chandu Biology Classes materials only I have collected these questions. See, IIT JAM 2024 from PYQ books of IIT JAM BT by this Chandu Biology Classes, we have the books, from that I have collected. You just see here, and if you are looking for the books, yes, you can just write in the chat box or you just directly contact to the mobile numbers given in the description box for books or any material kind of things. Okay, right. So look at the questions first. See, again all these are IIT JAM BT questions, or few questions are also from IIT JAM chemistry, which are easy only. Okay, see, look at these questions. All these are questions are like identifying order of reaction and what are the factors affecting, and this is based on what is the effect of temperature and rate of reaction. These things are there. I am going to explain everything like first order, second order, third order, how their graphs will be seen. Okay, so yes, this is one more type. And see here, for a first order reaction, what will be the relation between their half-life for this enzymatic kinetics. Okay, and enzyme kinetics is one of the very important topic when it comes to this bio students. Okay, yes, that like we are studying now Michael-Menten constant, constant, all these things. Yes, those things are very important again, which is connected to the our chemical kinetics, right? So which is very important. I will be discussing all these things first. Yeah, see, this many questions I have brought from last 10 years papers. I have brought these questions. Now let us understand the topic, what actually chemical kinetics explains us. Chemical kinetics. So what is the use of chemical kinetics? It explains or it deals with rate of a reaction, rate of a chemical reactions. It means, what do we mean by rate of a chemical reactions? How fast a chemical reaction is taking place or how slow it is going, and what are the factors affecting on this rate of a reaction. What I am saying, factors affecting rate of this reaction like concentration, temperature, okay, catalyst, these things are there. So these are some important factors to be discussed. Okay, and the next mechanism of a chemical reaction. These are the things must be studied here. Okay, right. And you know the chemical reactions having some orders. What do we mean by order? It means during a chemical reaction, if we change the concentration of one reactant, see generally how we will be writing the chemical reaction, A plus B giving rise to some products, if I say. Okay, now what happens to the rate of this reaction, whether it goes very faster or very slow or no change if I increase the concentration of A, or if I decrease the concentration of A, and if I increase in the concentration of A, how the rate is changing, and if keeping the concentration of A constant and if we are increasing concentration of B, how rate is changing. All these discussions must be understood using this chemical kinetics. Okay, right. So first of all, if I have a chemical reaction which I am indicating like this, see, I am indicating a chemical reactions like A plus B giving rise to some C plus D products are formed. Okay, and let us keep this stoichiometric coefficients like A number of this capital A reactants are reacting with this B number of capital B reactants and forming some products like Q number of C products are forming and P number of D products are forming. What is this A, B, QP? Here this small a, small b, QP are considered as stoichiometric coefficients. What do we mean by stoichiometric coefficients? For example, in order to understand, I am taking a methane molecule and treating this with water, oxygen, so that it forms CO2 plus H2O we are writing right now. So how many moles of A is reacting and how many moles of oxygen is reacting with this methane to form this CO2 and this 2H2O. Yes, look at this. You are saying two oxygen molecules combining with this CO2. Therefore, you are getting two water molecules are formed and one CO2 molecule is formed. Like this we are saying now. So the chemical reaction takes place with a balanced format. It means number of atoms product side and reactant side should be equal right now. So now when we are balancing a chemical reaction, whatever the number we are adjusting here towards this product side and the reactant side, the numbers which comes here before that particular reactants and before the particular product, those are considered stoichiometric coefficients. So here we have stoichiometric coefficients as 1, 2, 1, 2 like that. So here I am indicating them as generalizing for all chemical reactions as A, B, QP. Okay, I hope it is clear up to here. Now rate of a reaction or rate expression of this reaction can be written as rate of a reaction. See, just by explaining this, I am going to show you one question based on this that you can easily solve if you understood this. Okay, so look at this. Rate of a reaction can be written as, see, during the chemical reactions, what happens? Reactants converts into products now. Reactants converts into products. Now what happens during the chemical reactions? If we consider, I am drawing a graph here. See, as time goes on, what happens? Initially at the time t0, the reactant concentration will be maximum and product concentration will be 0 at initial case right now at the beginning of the reaction. So let us say here I am indicating concentration. This is indicating concentration, y-axis indicating concentration. Now what happens, tell me, as reactant concentration is maximum at the beginning, so it means you should start your graph from here. So as time is going on, what happens to the concentration of this reactant? Decreases, because it will be converting into the product form, so that you will get a graph something like this. Yes, so this curve is indicating what? Concentration change with respect to time for this reactant. Similarly, what about product? Concentration of product will be increased as time goes on. So initially it will be 0 and it will goes on like this. Okay, so the above curve indicates concentration of product and this below curve indicates concentration of reactant. Hope this is clear. So this graph is clearly saying concentration of product increases with increase in time and concentration of reactant decreases with increase in time. Okay, hope this is clear. Now what happens during a chemical reaction? Reactant concentration decreases right now. So what I am saying is rate of a reaction, if I say, it means change in concentration with respect to time. So dC by dt, it means what? Change in concentration by dt, it means change in time. Okay, so amount of concentration of reactants is decreased in unit time is called rate of that particular chemical reactant here. So chemical reaction rate, how can we write with respect to reactants? You can write here, what is our reactant here? A right now. So dA by dt you write first. Okay, which is equals to, again what is the reactant here? B, right? So dB by dt you write. And after this, if you observe, there are some stoichiometric coefficients here. Right now, these reactant stoichiometric coefficients are there like A and B. So write them as 1 by A here for this reactant. So rate of a chemical reaction is equals to 1 by A times dA by dt. Concentration of A, differentiation by dt with respect to this time here. T indicates time. Similarly for this 1 by B you write. Okay, what I told you, during the chemical reaction, reactant concentration decreases. Decreases means you just indicate the symbol negative. Okay, here also negative. Okay, once after doing this, this side you write product is forming now. During the chemical reactions, what happened? Concentration of product increases. So you can write concentration of product increases. So positive sign, and stoichiometry is there, you write 1 by Q and dC by dt, that's it, dC by dt. And for this place 1 by P d by dt. That's it. This is the way of writing rate of a chemical reaction. Okay. So now what is this dA by dt indicating? dA by dt indicates, dA by dt minus dA by dt indicates rate of consumption of A with respect to time, or we can also say rate of disappearance of A with respect to time is indicated in this way. Similarly, rate of deformation of B is also indicated as minus dB by dt. See, when I am writing rate of consumption of A, I am not including this 1 by A. We should not include this stoichiometric coefficient when I am saying rate of consumption or rate of formation. Similarly, if I ask what is the rate of formation of C in this reaction, so rate of formation of C they will ask. So it means what you see, dC by dt they are asking. Rate of formation of C means you should write formation of product, positive. So dC by dt you need to find in this reaction. So let us solve 1 or 2 questions on this, so that you will get more confident and more clarity on this particular discussion, right? So let me show you one question on this. See how easy it is. 2014 they asked this type of question. Just look at the reaction they are saying. This is a chemical reaction given here. Small a indicates stoichiometric coefficient and capital ABCs indicates their reactants and products. Okay, this is forming C plus D. So tell me the relation that holds for this particular reaction. How can you write this? How can you write this? Very simple. I know you can easily answer this. So if you are following the session, just tell me your answer in the chat box, because I am very confident that you have got clarity on this topic now. So just look at this. These are the reactant sides now. So it means rate of reaction is equals to, how can we write change in concentration of A with respect to time, dA by dt. What is its stoichiometric coefficient? A is there, small e, that is 1 by A. Since it is reactant, its concentration decreases, so add a symbol negative here. Okay, and this side again B is there, dB by dt, and here you write 1 by B, and this is also reactant, put a negative sign here. Okay, which is equals to, these are products now, so positive 1 by C dC by dt. Okay, and which is equals to 1 by D positive d by dt. That's it. So where do we have this kind of option? Yes, if you clearly observe this, final option is as it is whatever we have written. So it means our option number 4 will be perfect answer for this particular question. See how easy the question from this chemical kinetics right now, right? If the things are clear, just click on the like button once again, guys. Right, next let me give you few more examples. See, you should might get a one doubt that why you are inserting a negative sign over here. See, it is clearly explained from this graph. See, as time goes on, what happens to concentration of reactant? It decreases now. So whenever we are saying that change in concentration, that dR by dt, if I say change in concentration of reactant, so it is nothing but reactant concentration at time 2 and reactant concentration at time T1, that is T2 minus T1 we are writing. So we know T2 minus T1 is a positive term, because as time goes on this value becomes positive. But this one R2 minus R1, final concentration of reactant decreasing when I compare with the initial, therefore this term becomes negative. Rate of reaction should not be expressed in negative formats, it must be in positive values only. So if we won't insert this negative symbol for the reactant side, it will be a the value of this rate of reaction will be negative in terms of reactants. So we should not express our answer for rate of reaction in negative terms, it should be, must be positive. That's why we are inserting a symbol here itself, negative, in front of the reactants and products. Therefore what happens, that will nullify it, that will get cancelled out. So whatever the answer we are getting, that will be expressed in terms of positive values only. Hope this is clear why you are using these negative symbols in case of reactants. and product it will be plus only as concentration increases. So the value P2 will be greater than P1, so we will be getting only positive values. Okay. So just to adjust that rate of reaction in positive values, we are indicating here a negative symbol in case of reactants. That's it. This is the only line you should remember for the reactants. Okay, right. Let me give you few more questions here. See, again this is IIT JAM 2017 question, right. So just look at the question once. For a reaction 2A plus B gives rise to C plus D. If rate of consumption of A is 0.1, it means what? So what they are saying, rate of consumption, it is nothing but minus dA by dt is equals to, minus dA by dt equals to 0.1. How much it is? 0.1 mole per liter per second. Okay. Now they are asking rate of production of C. So what is the rate of production of this C as per the equation they are saying? Very simple. First of all, you need to write the rate of reaction, so that from that rate of reaction you will get a relation between rate of consumption of A and this rate of formation of C. So from that relation we can find this value that are asking in the question. So that is nothing but minus 1 by 2 dA by dt equals to minus dB by dt equals to plus dC by dt equals to plus dB by dd by dt. That's it. So what is the relation? So it is minus dA by dt equals to, I can write minus dA by dt equals to 2 times of plus dC by dt. That's it. So it means 2 into, so what they are asking? They are asking this dA by dt value they have given, and they are asking this dC by dt. It means what to do? See here, I can write like this format also, but we have this value now. So just what to do here? You just place 1 by 2 into, what is the dA by dt value they have mentioned here? 0.1, that is equals to plus dC by dt. Yeah, depending upon the values they have provided, use here in this form, in this equation you will get the other one which they are asking. So this is 0.1 by 2. So it is simply what you can write, 0.1 by 2 means this is nothing but, see what you can make, this is 0.5 into 0.1, that is nothing but 0.05 right now. So what is the production of C? dC by dt is nothing but 0.5. That's it. This will be your answer for this particular question. They are asking us to express in this numerical answer type. So this value will be 0.05. That's it. That's it. This will be the answer for the question. Hope this is clear. Whatever I have explained here, see just 1 by 2 dA by dt value is 0.1. So substitute over here so that you will get the values for this remaining things. So dC by dt will be 0.5 into 0.1, that is 0.05. That's it. Okay, right. Let's move forward with few more things. See, they are saying for a reaction of type A plus B giving rise to product, the unit of rate constant is how much, and the overall order of this reaction is how much they are asking. Okay, it's very simple. Rate constant units are given, they are asking what is the order of this reaction. Very simple. Let me explain you what actually the rate of reaction means. How can you write this? See, for example, A giving rise to some product. Okay, so now rate of reaction directly proportional to concentration of reactants in that particular reaction. So here what is the reactant here? A. So rate of this reaction is proportional to the concentration of this reactant, okay, with some power m. So here m indicates the order of reaction. What it is? Order of reaction. So this order of reaction is an experimental value. What I am saying, it is an experimental value. We cannot get it theoretically. We need to look into the experimental data in order to identify this m, order of the particular reaction. Okay. In case for a given elementary reaction they mention, if the reaction is mentioned as elementary reaction, then in elementary reaction whatever the stoichiometric coefficients are there, that will be their orders. Okay. For example, I am saying A plus B gives rise to some product. So I am saying this reaction is an elementary reaction by mentioning A plus 2B giving rise to some product. Then order with respect to A will be 1 and order with respect to B will be 2. Like this we can understand. But if they won't mention this is an elementary reaction, or if they mention something like a complex reaction, see chemical reactions are of two types. One is elementary reaction, another one is complex reaction. So complex reactions is like reactions which involves multiple steps. It will be having multiple steps, that is multiple elementary steps will be there. Okay, like generally if you are a student of chemistry, then you can understand that some chemical reaction takes place in multiple steps, like SN1 reaction is there. So first step is formation of carbocation, and the next step is attacking of that nucleophile. So two steps are involving, and here formation of carbocation is rate determining step we are saying. So it means rate of reaction depends upon the rate determining step. Okay, so chemical reactions are two types, one is elementary reaction, another one is complex reactions. Whenever an elementary reaction is given, whatever the stoichiometric coefficients of that reactants are there now, those values will be their orders. Okay, order with respect to A is 1, order with respect to B is 2. Okay, in case of complex reaction, that is a multi-step reaction it is. So every step in the complex reaction is considered as an elementary reaction. Therefore, the value of order for this complex reaction cannot be given. Okay, directly by looking at the theoretically we cannot give, that comes only from experimental data. Okay, I will show you one example how can we identify order of the reaction by looking at the data of these complex reactions. Very simple, just hold on for few minutes. Okay, right, do not get confused, do not get hesitated to ask your concerns in the chat box. You just express whatever the concerns you have, or try to listen here very patiently. At the end you will definitely feel yes, you have studied something, or you have got something very useful thing in the class. Okay, right, look at this. So now what I am saying, rate of a reaction is directly proportional to concentration of this reactant. So from here I can remove that proportionality, and I can write a constant K multiplied with concentration of A to the power m. Okay, so now this K is called rate constant. What is K? K is called rate constant. Okay, now in the exam they will ask what are the units for this rate constant. Okay, so what are the units for this rate constant, they will ask. That I have shown you, again I will show you once after understanding the concept. So always remember, rate means what? Rate means what? Change in concentration. Rate means, rate of a reaction means how fast it is taking place, we are saying now, that is what? Change in the concentration of reactants or product with time, change in time. So concentration units are what? Mole per liter. What is that? Mole per liter. And for this dt means time, right? So for time you can say second inverse, minute inverse, like that. So let us express in terms of second for some time. Okay, so for rate you can say mole per liter liter, and second inverse will be the answer for this rate units. They ask for rate, this could be your units. For a rate, the constant, these values will be, for a rate the units will be always same, but a rate constant units changes depending upon the order of the reaction. For example, here to identify what is the rate constant units for zero order reaction. Zero order reaction units they will ask. What are the units for K for this zero order reaction, they will ask. Very simple, when they are saying zero order, it means m value is 0. If m value is 0, something power 0 will be 1, right? So this term becomes 0. It means R equals to K. So whatever the units there for R, that will be the units of this K. Okay, in case of zero order reaction. Therefore, what is the units of K in zero order reaction? Simply you can say mole, that is mole per liter per second, that's it. Okay, this is for zero order. Similarly, they will ask what is the units of K for first order reaction. First order reaction. It is also very simple. What to do first? Okay, so you can put this value of m as 1. So after keeping that, so you can get R by A power m right now. So now let us generalize this. What is a square bracket indicating? It is simply a concentration, molarity indicated. So molarity power m, concentration is nothing but molarity I am writing. So that is molarity indicated with m, capital M. Okay, to the power m. M indicates capital, small m indicates what? It is the order of the reaction. What is the units for this R we got? Mole per liter. This is nothing but molarity and second inverse. Okay, this is molarity into second inverse. So finally, what are the units for K? This is nothing but m is there here with power 1 and here like denominator m, so I can write 1 minus m second inverse. This is a generalized equation for finding units of rate constant for any order reaction, So for example, let us understand the units of first order units of K for first order reaction. Okay, so what to take here? M value you take it as 1, small m value, or you consider it as n. N indicates what here? Order of the reaction. So just K take, K is equals to, units of K equals to molarity power 1 minus n second inverse we are writing. So n value is how much I am saying? First order na 1. So m power molarity power 1 minus 1 second inverse. 1 minus 1 means 0, something power 0, it will be 1 into second inverse. So what is the units of first order rate constant? It is second inverse. Okay, so that's why whenever if you observe questions based on carbon dating or radioactivity, so there will be seeing you like you are seeing that the units for the rate constant will be expressed in terms of second inverse, because all those radioactive reactions are first order reactions. What is that? Radioactive reactions are first order reaction. Yeah. So Udit, sir, what will be the duration? Yes, it will be almost of 1 hour to 1 hour 15 to 30 minutes. Okay, right. Yes, can you tell me what is the rate constant for second order? What is the rate constant values, units for second order? So just insert n value as 2, molarity power 1 minus 2 second inverse. Okay, so this is nothing but molarity power minus 1 will get, second inverse will get as it is. So molarity is nothing but mole per liter, so it means mole inverse a liter second inverse, that's it. Very, very important. Finding the units of rate constant help us in many cases, like by looking at the rate constant units we can identify what is the order of that reaction right now. So that's why understanding the units of rate constant, finding the units of rate constant is very, very important from this generalized formula. What is the formula I am saying? Just take molarity power 1 minus n, or you can take concentration power 1 minus n time inverse. This is the generalized formula for finding rate constant units. And for you, my question here is, what are the rate constant units for third order reaction and fourth order reaction? Just tell me what are the units for this third order and fourth order in the comment box. Okay, whenever you are watching, whether it is live recorded, so if you are watching, you just answer me your question for this particular question, for this question in the chat box. Okay, now look at this, very easy. For a given reaction, the unit of rate constants are like this, then what is the order of this reaction? Very easy, right? So look at the rate constant units. By looking at this rate constant unit, we can easily determine this, which order it is, we can easily predict it. How it is? See rate constant units, what I have generalized it, concentration to the power 1 minus n time inverse, right now. So time can be expressed in minutes or seconds. So here it is expressed in seconds, so second inverse, fine. The next here it is mole per liter. Simply it is mole per liter means what is the value of n here we can keep. Therefore concentration like mole per liter remains as it is, mole per liter only. So if you place this n value 0, then this will be mole per liter only and second inverse. It means what is the n value we got here? 0. It means what is the order of this reaction? 0 order reaction it is. A. So option A will be the answer for this particular question. Hope it is clear without having any confusions, right? Right. Let us move forward with a few more things. Look at this, understanding the values, like what is the order of these reactions by looking at the data. See, just look at the data once. What they are saying, the rate of reaction is expressed as R rate is equals to K into A to the power M B to the power N. Okay, the rate constant K for this reaction, see again rate constant values are given. K is equals to what they are saying, mole power minus 2 liter square and second inverse. So very simple. So what is the value of N in our generalized equation, so that we will get this unit. See, what is the generalized equation for generalized formula for this rate constant units? Concentration to the power 1 minus N time inverse I have given right now. So what is the value of N here I can place, so that it becomes units like this. Okay, how simple it is? So by placing N equals to 3, you will get concentration to the power 1 minus 3, that is nothing but 1 minus 3 is nothing but minus 2 and a time inverse. So that's it, time inverse. So for time inverse we can get this second inverse. Okay, for this we can get second inverse. Concentration in power minus 2 means nothing but mole power minus 2, and per liter we have in the denominator here, concentration means mole per liter, that per liter, and this is power minus 2, it is nothing but liter square, that's it. Okay, so what is the order of this reaction? Third order. Okay, what is the order of this reaction? Third order. Okay, so it means M plus N values are equals to 3. Okay, now they are asking the possible values of this M and N are, see total value should be 3, but if I place 1 plus 1, M is 1, N is 1, this is only 2 now, no, this is not the correct. See, this is 1 and 3, it will be 4, this is also not the correct. See here, possible value is M can be 1, N can be 2, or in the opposite manner also. So total sum will be 3, so option 2 will be your answer for the question. If you look at the fourth option, 1 plus 4 is 5, this cannot be the answer. Okay, so it means option 2 will be the perfectly correct match for this particular question. Okay, hope the explanation is clear without any confusions, right? Right, let us move forward again. We have one more model question here, let's understand this. Let's understand this. See what they are saying here, just read this paragraph easy, it is very easy but looks lengthy but very easy. Just try to read the definition side, data given for making an equation like this. See what they are saying, for a reaction 2A plus B gives rise to P as product. By doubling the concentration, initial concentration of both the reactants, the rate increases by a factor of 8. It means what is the rate of this reaction? You can write a rate is equals to K into A to the power M and B to the power N we can write. That's it now. From this is what the initial rate of reaction we have written by looking at this given data. Okay, given equation. So now what they are saying, by doubling the initial concentration of both reactants, rate increases by a factor of 8. It means if I consider this is R1, this is rate equation 1 as first equation, and what they are saying, they are doubling the concentration of A and B both, so that it becomes R2. Okay, so this R2 is now what? 2 times of A to the power M and 2 times of B to the power N. Okay, this is equation number 2 I am saying. Okay, so by the doubling the initial concentration of both reactants, the rate increases by a factor of 8. It means this is becoming 8 times of initial concentration, 8 R1 it is becoming, R2 becoming 8 times of initial concentration, that is nothing but if I doubling the concentration of A and B like this, it is becoming 8 R1. Okay, that's it. Okay, and next read the question, still it is there, whereas by the doubling the concentration of B alone, the rate increases 2 times. It means R3 I am writing here. See, concentration of A is remained same, but concentration of B is doubled. Okay, it is doubled. okay, so that the rate is becoming, so that rate increases 2 times, it is means you can write 2 times of R1, that's it. Okay. So what is the rate law of this particular equation? It means what do we need to find? We just need to find this m and n value, so that we will get one of this option. Very simple. See, look at the first equation, try to make this equation in the form of first equation. So this is nothing but R3 is equals to K a to the power m and b to the power n, and here we have 2 to the power n, I am writing here 2 to the power n. So if you observe this term, this whatever the term, extra term we have, that is coming from 3, this term is nothing but R1 only, no? R1 we are saying, R1. Okay. So it means this should becoming R1 should become 2R1. It means what is the value of n here, 2 power n is there, na? What is the value of n I can place, so that it will become 2. So n can be just 1, na? So n equals to 1, that's it. It means what you got to know, the order with respect to B in this reaction is 1. Okay, order with respect to B in this reaction is 1. Okay, and the next thing is look at this second equation, so that we can get this m value, because order with respect to B is 1 here, so that we got here 1 here you can place. Now m value I need to get here. See, how can we get this? Is very easy. Look at here, guys. See, it is total overall value is 8R1. 8R1 you write as it is, which is equals to R2, that is K. Again I am writing here, just observe what is the data mentioned here. 2 power m I am writing, 2 power m, and 2 power 1 it is 2 power 1, and k into a power m, b power 1, that's it. Okay. So if you see, this data is as it is as a first option or first equation. So look at these values, what is the value of this m I can place, so that it becomes number 8 here. So 8 it should become 2 power m plus 1 should equals to 8. This is nothing but 2 power 3 now. 8 means 2 power 3 now. So m plus n equals to, m plus 1 equals to 3. So m equals to 2, that's it. So order with respect to A is 2, order with respect to B is 1. So option 3 will be a perfect option for the question. Hope whatever I have explained, it is clearly understood without having any confusions. If you have still confusions, just go back for few seconds, again rewatch it. Okay. So for getting more clarity, just pause the video when you are watching and try to solve this question in the same manner, so that you will get complete clarity, because some students are new to chemistry, that's why I am explaining this. I am slowly trying to inject this into your mind. Okay. So again, let us move forward with few more questions. Hope this is clear without having any confusion. Let me explain one more question if I have in a similar manner. No. Okay. I hope everything that we have discussed till now are clear without having any confusions, right now? Right. So once you just try questions on these, if you are not having any questions, just take IIT JAM chemistry questions or CUET PG questions you take for this chemistry related questions, and you can solve. There are many questions. Even if you won't find that books, just take any IIT JEE materials or NEET materials, having this type of questions. Do not solve all the questions, just look at your PYQs from your IIT JAM BT. Similar questions you search in your the material that whatever you have available now as of now. So just go through them and solve that. Okay, that's it. Do not waste too much time on other things by solving unnecessary things here. Okay, right. Let us show me, like let us give me a few more questions. Okay. The next thing is, here till now you got to know how to find order of reaction by looking at the data, that last question, and finding the rate constant, looking at the rate constant, finding the order of that reaction. This is also clear, and writing the rate of reaction is also clear. Okay, now look at one more thing which I am saying here, that is connected to the previous discussion. See, I am saying A plus B giving rise to some products. Okay, so here I can write rate, it means like rate of that reaction is directly proportional to concentration of A and also concentration of B. Okay, and replacing this proportionality with some constant K, having some order M and N here. Okay, concentration of A and concentration of B to the power N I am writing. Okay, this is how we are writing. So this thing which we are writing here like this is called as rate law. What is that? Rate law or rate equation. Okay, rate law or rate equation. Okay, right. So rate law means nothing but change in rate means nothing but change in concentration of reactants and product with respect to time, like this we are saying now. This is nothing but K, A power M, B power N we are writing. So now we will understand each order of reactions, like what is zero order reaction, what is first order reaction, all these things will let us make it clear. Okay, first thing here I mentioned is zero order reaction. So what exactly zero order reaction? See, a reaction A converting into some product, reactant A converting into some product. So if I say this is zero order reaction, rate of reaction proportional to concentration of A, since it is zero order, here whatever the M we are writing, that should be written as 0. Something power 0 become 1, right? So R is equals to K naught into A power 0 I am writing, this is nothing but R is equals to K naught. So simply what I am saying, your rate constant value and the rate of that reaction value will be same and having same units. Okay, in case of zero order reaction, because this whole term becomes 1 now, A power 0 something power 0 is 1. Okay, that's why it is 1. Okay, clear now up to here? Right. Let me give you few more things here. So now change in concentration of A. What is our reactant here? A, right? So rate means what you can say? Change in concentration of A with respect to time. Indicate symbol negative since it is a reactant. Okay, this is equals to K naught. Okay, now try to integrate this minus dA by dt equals to K naught dt. Okay, so we can just send this there, you will get this equation. Try to integrate both sides. Okay, so at time t0 we have concentration of A as A naught. What is the concentration of A at initial? A naught I am saying. Okay, and what is the concentration of A at some time t? This is AT I am saying. So same thing, sometimes depending upon the condition and depending upon the requirement, they will indicate. See, A is giving rise to some product like this, they will say at a time t0 initial concentration of A is mentioned as either A naught or they will mention it as purely like small a. Okay, after some time t, what happens is this A will be converting into some product now, it means concentration of A decreases, that is A minus X they will mention, or simply concentration of A at a time t they will mention. Both ways are correct only for indication of reactant concentration. How much concentration of product is formed? X concentration. This is X decrease, it means that X is formed as this product. Okay, that's it. So do not worry whether what units they are using or what way they are indicating, both ways are correct only here. Okay, so finally what we'll get here, right? So substitute this, see integration, differentiation, you can remove these things so that you will get A to the power, like upper limit is AT, lower is A naught with a negative symbol, here K naught, T to the power, here upper T and lower 0. Okay, so integrate like applying lowers and upper limits, you just write it AT minus A naught with a negative symbol, that is A naught minus AT you will get, right now. Next this one becomes K naught T. Okay, so from this what you can write, AT is equals to A naught minus K naught T. Okay, why I am saying all these things, you are going to get a graph from this. Based on graph also they may ask you the question. Okay, so this indicates what? AT indicates what? Concentration of A at a time T. It means, for example, we are doing this reaction, we have did this reaction till 10 minutes. Now at this 10th minute, what is the concentration of A in the reaction? So that is what concentration of A at a time T indicating here. See, we know that it will be definitely lesser than the initial concentration, that's why initial concentration, that is A naught minus some value is there. So that value comes from multiplication of T with K naught, that's it. This is what it is indicating. Now we need to draw a graph for this. How this is looking like, AT is equals to minus K naught multiplied with T plus A naught. Okay, this is like Y equals to mx plus C type graph right now. So right here AT and here T. Now how they are changing? See, having negative slope with positive intercept. So it means it will be like this. Okay, this is the indication of the graph. And this value here indicates what? Your A naught, initial concentration. Okay, and this is this one, what I can say, slope is how much? It is minus K naught. Okay, try to remember this, because based on these things also they may ask a question. I will show you the question that is formed from this particular equation itself. Hope whatever we have discussed it is clear. Now remember some examples for zero order reaction. See, complex reactions, like zero order reactions are complex reactions, you can remember. Zero order reactions or complex reaction. I am not saying in the reverse manner. See, complex reactions are zero order means no, that is not true all the time. But zero order reactions are complex reactions. Okay, remember this statement. Okay, next. This is about zero order reaction. Next we have first order reaction. First order reaction, how can you say this? See, if A is a reactant forming some product, then you can say rate of this reaction is proportional to concentration of A. Since it is first order, here power should be 1. So rate will be equals to K to concentration of A power 1. Like this you can write. Okay, and now since it is first order, I am writing K1 here. Okay, and I already discussed how can you find the rate constant units, K units and all. Okay, so now this one, rate means nothing but change in concentration of reactant with respect to time, that is dA by dt you can say. So with a negative sign, because it is a reactant, minus dA by dt is equals to K1A. Okay, from this what I can write, minus dA by dt, this bring this A this side, this becomes 1 by A, which is equals to K1 dt, that's it. Okay, so now apply the integration on both sides again. So what you will get here, from initial concentration A and final concentration A minus x, or you can take A naught and AT. Okay, and this is at time t0, this is at time t. Okay, integration of 1 by x dx is ln x, so that here you will get ln of A by A minus x, applying the limits. This will be K1 t, that's it. So this is the equation you need to remember for first order. So these are the integral equations of first order, zero order we got till now. So now here what you can write, the time required for completion of some x percentage of reaction here, x amount of reaction here will be written as t equals to 1 by k ln of A by A minus x. Okay, and here I can also write t is equals to 2.303 by k log A by A minus x. Most of the questions are on this formula. There are many questions on this particular formula itself. Okay, so whatever the formula, see guys, I have already made it very crisp. Do not think too much notes are given here, no. So it's very crisp, just looking at the questions PYQs, I am targeting the topics here, okay. So try to make all this sheet, formula sheet out of this and look into it, try to solve the questions once again from the same IIT JAM BT PYQs always, and after doing that go to the other exam papers, okay. I hope you got point whatever I am saying here, right. Right. Now they will ask something like this: what is the time taken for completion of half of the reaction? It means initial concentration of this reactant is A, I am saying. So this is at time t0. What is the time taken for completion, like half of the reaction to complete? It means concentration of A should become A by 2. So what is the time here? You should call it as half life of this reaction. So what is the T half of this reaction, they will ask for this first order. So T half is simply you can write, so 2.303 as it is by K as it is log this A minus X is how much? See, X is this much amount, it is completed. So A minus A by 2 means A by 2 only again. So this will be A cancel, you will get log 2. So log 2 is 0.3. So 2.303 into log 2 is 0.3 I am writing and by K. So this will be around 0.693 by K. Okay, this is the T half of first order reaction. Okay, this is the T half of first order reaction. If I ask in the same way for the zero order reaction, what is the T half? See, you got for this T for the zero order reaction as equation in this manner. See here, so you got something like this. So what I am asking here, T half for this reaction, if I ask, what you will do? A naught is the initial concentration, A by T is the present concentration, that is nothing but half of the initial concentration, A naught by 2, okay, A naught by 2, this will be K naught T, A minus A naught by 2 is nothing but A naught by 2 only now, again, right. So this is K naught T. So I want a time required, that is T half, this is T half of zero order reaction is nothing but initial concentration by 2 K naught, that is it. Initial concentration by 2 K naught will be your first order, zero order half life period. Okay, and for first order it is 0.693 by K. So if you look the two equations for zero order, I am writing T half of zero order, I am writing it as initial concentration A by 2 K naught I am writing. So this half life of the first zero order reaction, see, half life of the zero order reaction is directly proportional to the initial concentration of this reaction right now. So it is directly proportional to the initial concentration. But if you see half life of the first order reaction, it is independent of initial concentration. Yes guys, you can expect a question in this manner, like given 4 statements, out of 4 which is correct or which is incorrect. First statement they will give for a zero order reaction, rate is independent of initial concentration, initial concentration. Is this correct or not, they will ask. And second statement they will ask, B, half life of T half of zero order reaction is independent of initial concentration, they will mention. And the next third statement they will give, for a first order reaction, rate is independent of initial concentration. Next, for a first order reaction, half life is independent of initial concentration, they will mention. So tell me, out of this 4 statement, which is correct? See, we know for a zero order reaction, rate is independent of initial concentration because A to the power 0, something power 0 is 1. So rate is independent of initial concentration. So first statement is correct. Option A is perfectly correct. You can make a multi-selective type question from here, MSQ type. Second question, if second option if you see, T half of initial zero order reaction is independent. No. So T half of zero order reaction is directly proportional to initial concentration. It means this is wrong. You do not choose that. And option C, if you check, for a first order reaction, rate is independent of initial concentration. No. Rate for first order reaction is directly proportional to concentration of reactant. So it means rate is independent depending on the concentration of A. It is not independent, it is dependent. So this statement C is incorrect. So look at the option number D. They are saying for first order reaction, T half is independent of initial concentration. Yes, T half of first order reaction is independent of initial concentration. Yes, this is true, right? So it means last option is also correct. So A, D are correct, B, C are false here. I hope you got, yes, this kind of questions you can expect as MSQs, like multi-selectives in your exam. Okay, hope concept that we have discussed here is crystal clear, right? Let us move forward with few more questions. Right. Let me give you one last order, that is second order reaction, then we can solve the questions. Second order reactions. Okay. See, I hope you are aware of drawing the graphs, looking at the equations. See, second order means rate is directly proportional to concentration of A to the power 2. Why to the power 2? Order of this reaction is how much? 2. If A is giving rise to some product, I am saying this reaction follows second order. It means you should definitely put the power 2 for the reactants. If it is A plus B, then you can take in this way also. Rate is directly proportional to concentration of A and concentration of B. By in what way I am saying rate of reaction, total order of this reaction is 2, second order. So it means you can place 1 and 1 here, or here you put directly 2 here and here 0 can also be possible. In other, like many ways are possible here, but let us generalize this. Rate of reaction is directly proportional to concentration of A to the power 2. For understanding purpose you can take it like this. Okay. So now what I can say, change in concentration dA by dt is equals to K2 A to the power 2. Okay. This is a decrease in concentration because it is a reactant. So now upon integration you will get like integral of 1 by A square dA, 1 by x square dx will be minus 1 by x. Okay. So here also you will get in the same format. So therefore you can write it as final equation I am writing here, just see, K2T is equals to you will get it as 1 by A minus x minus 1 by A. This is the equation you will get as a final equation for this second order equation. Means time required can be written as 1 by K2 into 1 by A minus x minus 1 by A, that is it. Okay, this is the equation for second order. Now let us simplify or let us generalize time required for any order, nth order I am considering. So for any nth order reaction you can just simply look at this, what I am writing, T is equals to 1, definitely in the denominator we have K, so you can write K power n, like K we required, Kn I am writing, not A power, it is just Kn, nth order reaction. So now here, since it is a second order, what you are seeing here you are seeing 1. It means it is second order, you have 1. It means if it is third order, you will be seeing 2. So if it is fourth order, you will be seeing 3. So you just make it is n minus 1 here. Okay, that's it. And in this bracket, open the bracket and A minus x you are seeing now. See, it is second order, so therefore you are seeing the power as 1. If it is third order, you are seeing power as 2. So you can see A minus x to the power n minus 1 minus 1 by, here again A power 1 is there, for second order it is 1, for third order it will be 2. It means you can write A power n minus 1 for an nth order, that is it. So T, time taken for particular nth order reaction will be written like this. So n can be 2 to anything, not it cannot be 1. So it cannot be 1 because for first order I already discussed, formula looks different, with the log terms it will be. So you should not use this for first order reaction. Okay. So second order it can be third order, it can be fourth order, it can be so on, but not the first order. Okay, hope whatever we have discussed everything is clear. Now from this they will ask half life of this second order equation. How can you make T half of this second order equation equals to 1 by K2, you write as it is. T half, it means A minus X becomes how much? X. X represent the amount of A converted into product. Half is converted down A minus of A by 2, that is A by 2 you will get, that is 2, if you send up you will get 2 by A minus 1 by A. So this is T half is equals to 1 by A K2, 1 by A K2, that's it. This is a second order equation, you can remember. Okay, right. So finally if you see all this equation that we have discussed till now, like half life, you will be having a conclusion here. What is the conclusion? See, you can derive half life for any order reaction using this equation now, because you put A minus X as A minus of A by 2, then you can send that denominator 2 into the numerator, you will get one equation. Okay, right. You can try that if you want and tell me here. See, what happens is for 0 order T half, you got it as, for 0 order reaction, T half of 0 order reaction. What I am saying, 0 order you got it as, T half is equals to A by 2K naught you got, A by 2K naught you got. For first order you got as independent, A power 0 you got, that is independent, like 0.693 by K we are writing, K1 we are writing. For second order we got it as, this is for first order. For second order it is like, second order you are writing it as A, see A is in the denominator, 1 by A you got, it means it is inversely proportional. So from here you can say T half for second order and follow other orders, second order, third order, fourth order, all these things follows as A power n minus 1. Okay, this is T half relation for second order. T half relation for first order is like this, independent. T half relation for 0 order is directly related, directly proportional, right. These are the things to be remembered from this particular topic here. Let me show you some questions here. Now look at the question. Rate versus concentration curves are given and they are asking us to identify the graph corresponds to which graph, which order. See, P graph corresponds to which order? First order, second order, 0 order. Very simple. Rate of a reaction directly proportional to initial concentration of reactants we are seeing right now. So if the reactant concentration is taken as 0, it means power 0, it means the concentration of reactant to the power 0, it means order of the reaction is 0 if I take, it means rate is independent of concentration of reactants right now. Reactants R is equals to a constant K naught. So this will be the scenario in case of 0 order reaction right now. So for this 0 order reaction, rate of reaction is independent of initial concentration. So independent means you will get a line like this. So first curve, first graph indicates a 0 order reaction. Similarly, if you observe second graph, so rate is directly proportional to concentration. It means rate you take K and A to the power 1 you put. See how they related, rate and concentration here, concentration of A. See y equals to mx type graphs right now. So what is our slope here? K. So we will get a straight line like this. Okay. So this is for which one? It is for first order curve. So this is for first order. This is for first order. Okay. Similarly, try to identify this last graph. Yes, it is very easy. For last graph, R is directly proportional to concentration of A to the power something. See, R they are saying it is for half order, 0 order. No, it cannot be 0 order. So let us take it as 2. So now what happens? R is equals to K A to the power 2. How they related? R here, A2 here. So as concentration of A is increasing, exponentially R will increase now. So we will get a graph something like this, right? So it means this graph corresponds to second order, that's it. Okay. So 0, first, second. So option 2 will be the perfect answer for the question. Okay, hope this is clear, right. For a zero order reaction, 50% completion taking place in 30 minutes. Then the time from start to the start of reaction required to 80% completion. Very simple guys, whenever they are asking this X percent, Y percentage of reaction like 80%, 70%, 20, 30%, whatever might be the order of the reaction. So just to take the integral equations we got right now. So for zero order you got X by T. For first order you got something like this, K is equals to 1 by T ln of or log of A by A minus X we got, here multiply with 2.303. This is the integral equation for first order. Like this you take, what is the percentage they are saying? 80%. It means what? Here A is giving rise to some product, you say, if A is the initial concentration of reactant, that is nothing but 100%, that is 100 you take. After some time T0, after some time T, what happens? Some of this concentration of A decrease, that is converting into product, that is A minus X I am saying. Okay, so what they are saying, 80%, here 50%. So here X represent amount of reaction completed. So in the first case it is 50%. It means T 50% you can say, that is equals to 2.303 by K log, how much A initially it is 100. How much it is completed? 50% completed. A minus X will be how much? 100 minus 50, that will be remaining will be 50 here, okay, divided by, and T one more is 80, T 80% will be 2.303 by K log, how much it is? 80% now, initially 100, how much it is completed? 80, it means X is 80, 100 minus 80 will be 20 here, you take here 20, that is it, okay, done. Up to here it is done. See, this constant values will be removed here. Next, what to do next? Look at this. I can write this as 2 times. Okay, so you have log 2 in the numerator, and you can write T50 by T 80% is equals to, here in the numerator log 2, and in the denominator you have log, this is 5 times, you have log 5. Okay, log 5. Okay. Yes, 80% completion means log 5. Okay. Yes, next what to do here? What they are asking? The time required for 80% completion. So it means log T 80% is equals to T 50% multiplied with log 5 by log 2. Log 2. So log T 50% is how much they are saying? 30 minutes. You take here 30. Multiply this with log 5. So log 5 is how much? You can write log 2 plus log 3 now. Log 2 is 0.3, log 3 is 0.48. It means 0.78 will be the log 5 value. Here 0.78 and here 0.30. So you just simplify this, you will get T 80%. So one of the option from 4 will be there out of this. Okay. So this is 78 by 30 you can take and simplify that. Okay, and you will get one of the 4 options. Okay, right. Hope whatever we discussed here, everything is clear. Next, tell me for this, again same question is there. See, this is for which order they are saying? They are saying it for zero order. Whatever we have calculated, this is for first order. This is whatever the calculation I have made, this is for first order. Okay, if they are asking for 0, see, for this first order T 80% will be how much now? This will be, just simplify this, 0.7 by, it means it will be 30. So 78 minutes you will get. See, same question, I am saying same question, if they ask for first order, 78 will be the answer, first order. If this question only, if it is zero order, it is very simple for zero order, I will tell you here itself. See, for zero order, what you can see, zero order means what to take here? Time required will be taken as X by K. Okay, how we got this integral equation that we have discussed. Okay, so from this T half, it means X is amount of consumed, that is 50%, remaining is how much, that is remaining is 50, that is A by 2 K naught we have, this is for 50%. They are saying again T 80%, so T 80% means again X is how much, 20 na. See, it is simple man, see, you just take T X percent by T Y percent equals to X by K naught multiplied with this one Y by K naught. Simply you remove this 2 K naught, so that you will get X by Y. So what is X, they are saying 50, and what is the Y, they are saying 80, that's it, this is your answer. Okay, so T X by T Y will be 50 by 80. Okay, after this if you simplify, see T X percent is how much they mentioned, 30 minutes, take here 30, so T Y will be now 30 into 80 by 50. Okay, 0 0 cancel, so that 24 240 you will get 240 by 5. So this will be how many times, 4 times 40 is 80. So 48 minute will be the answer for this particular question. See, 48 minutes will be there for your answer. Okay, so this is for zero order and this is for first order. Hope the complete discussion of zero order, first order is clear without any confusion. Okay, see guys, why I have taken this first, because I have considered this was as a first order reaction, but later when I have seen same question here which is specifically mentioned zero order, then I calculated zero order. Okay, so yes, for zero order it is 48, for first order it is 78 minutes without any confusion. Hope everything is clear. Okay, so simply whenever you got confusion or you forgot about the formulas, how can you calculate? So zero order means you just take T 50%, like X by T means A by 2 K naught, and 80% means what you can say, see you got X now, that is nothing but 80%. So you take X as 80 by K naught. See, initially A is how much here, 100 now, so 100 by 2 means 50. So 50 by K naught you take, here 80 by K naught you take, K naught cancel, so you are remaining with this thing only. So simply you remember T X percent by T Y percent for zero order reaction is X by Y, that's it. This is the relation to find this type of questions. Okay, in case of zero order. In case of first order, what is the relation you will get? T X percent by T Y percent is equals to log 100 by 100 minus X by log 100 by 100 minus Y, that's it. These are the two relations you remember. This is for first order, zero order, this is for first order, that's it. You can calculate this type of model questions, okay, without any confusions, right. See, again you know guys, the question which I have solved previously is from IIT JAM BT, and this is the question, same question appeared in 2018 without changing, given a simple single thing also given for IIT JAM chemistry. Okay, right. So that's why I am saying, if you have books of this IIT JAM, just take similar questions that are asked in your exam and try to solve them. Okay, right. Next, look at this graphs given here. The graphs PQR shows a variation of rate constant with temperature. The relations represented by PQR respectively are very simple. See, P they are saying Arrhenius type, and Q enzyme catalyzed reaction, and R is a chain reaction, they are saying. Very simple. How can we identify? See, Arrhenius reaction, what is this Arrhenius equation? See, Arrhenius equation gives a relation between change in rate of a reaction with a temperature. So what is that Arrhenius equation? K is equals to A into e to the power of minus EA by RT. Here K represent a rate constant, and here A represent a normal constant, here Arrhenius parameter you can say. EA represent activation energy by RT. R is a universal gas constant, and temperature. See, they are exponentially related. So if temperature is increased, rate of reaction also increases. So temperature versus rate constant of a reaction will looks like this, So the first curve is an Arrhenius curve, okay, first one is Arrhenius type you can say, and the second one, if you observe, second one you can see this is enzyme reaction right now. So enzyme graph will be like this, see we can get a curve like this, in your books it might be like this. Yeah, we will be seeing maximum efficiency here, a maximum reaction here. So it means this is for enzyme kinetics, okay, enzyme catalyzed reaction, and this curve represents for chain reaction. So you can say Arrhenius enzyme catalyzed, and R is for chain reaction. So option 1 will be perfect here, okay, right. So can you match this based on our discussion? Can you match this based on our discussion? See, they are saying zero order reaction. Zero order reactions means what we got here? We got A naught, AT is equals to A naught T minus K naught T, A naught minus K naught T we got, okay. So it means we can get a graph like AT versus T. In what manner we will get to see? This is Y equals to minus M X, this is plus C is there. So you will get a negative slope like this. So you can say for zero order reaction, say reaction, for the reaction match the order of the reaction in the group 1 with the corresponding linear plots in group 2. So we will get a linear plot for zero order reaction for concentration of A versus time. So A versus time will be for first order, and for second order, and for this is for zero order, for first order will be ln of A versus time you will get, okay. You can draw that from this thing, see this thing you can draw. T is equals to 1 by K1 ln of A by A naught by AT. From this you can draw, you will get it for first order, and this is for second order, 1 by A versus time will be for second order, okay, that is it, okay, right. And this is just a first half, half life of the first order reaction based question. You just try this. If you are really facing difficulty to answer this, I will be explaining in the next session, okay. So this is about the session, guys. So just those who joined late, you just go back and rewatch it. You will definitely get clear cut explanation or clear cut clarity on complete discussion. So have some patience, go back and like look into it once again, okay. You will get complete clarity, and once after watching this, you no need of watching here and there again on whatever the topics we have discussed with these questions, okay, right. Let me show you any other question. Yes, this is one more question. Yes, you can try these questions, consider this as a homework questions, like see T 87% is 30 minutes they are asking. What is a T half life? Okay, I told you how can you use that T x percent by T y percent formula for calculation of this kind of model questions, okay. Try that. If you are really facing to answer them, I am going to explain in the next session on this chemical kinetics, okay. So thanks for watching. Just stay connected with Chandu Biology Classes. Thank you. Wow, 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 wow.